Dear students, very good morning. Today we are going to find the important problem under area evaluation. The question here is to find the area of ellipse. To find the area of ellipse, the equation of ellipse will be given in the question paper itself, or you have to write. So here the equation of ellipse is given by x square by a square plus y square divided by b square equal to 1. Okay, so we want to evaluate the area of ellipse x square by a square plus y square by b square equal to 1. So how to find the area of this ellipse? First of all, we know that how to draw the ellipse. Okay, we know how to draw the ellipse. So I am taking two axis lines. So with this axis line I am drawing an ellipse. Okay, I am drawing an ellipse. Okay, so this is the ellipse corresponding to the equation given there. The center is 0, 0. Okay, this is x and this is y. The center point is 0, 0. So after drawing the ellipse, we want to identify the limits. So this line is x-axis. So here in x-axis y equal to 0, and in y-axis x equal to 0, and in y-axis x equal to 0. Okay, and what about this point? Okay, what about this point? This point is given by B or A. You have to identify correctly. So, okay, we have to identify very correctly. So since it is on x-axis, this point is x equal to A. Okay, this point is x equal to A, and this point is x equal to minus A. Okay, and this point, and we have to identify this point also. So this point is y equal to B, and this point is y equal to minus B. Actually I am telling as point. Actually they are not point, they are the lines. Okay, I am mentioning everything as point, but actually they are not point. So this point is called minus a, 0, and this point is a, 0. This point is 0, B, and this point is 0, minus B. Okay, if I draw a line here, this line is y is equal to minus B. If I draw a line here, this line is y equal to plus B. If I draw a line here, this line is x equal to A. If I draw a line here, this line is x equal to minus A. Okay, so these are the fundamental things you have to keep in mind. One more thing you have to keep in mind is, now if you want to find the area of ellipse, means what will be the area of ellipse? The area of ellipse will be swept by the area covered by one quadrant into 4. Okay, area covered by one quadrant into 4. Okay, so it is enough to find the area of one quadrant. And after that, multiplying it with 4, we can easily identify the area of other quadrants. we can easily identify the area of other coherents. So in this one coherent, I am considering this positive coherent. Okay, because in the first coherent both x and y are positive. So here now I have to consider area equal to, okay, area of ellipse equal to, so simply I am putting area A. Okay, area, okay, area of ellipse equal to area of ellipse equal to 4 into 4 times of area of one coherent, 4 times of area of one coherent. Okay, so area of one coherent, okay, one coherent. Okay, you can take any one coherent, but it is preferred to, since area is positive, always you prefer to choose a positive coherent to make our problem, to make our steps very easy. Coherent, okay, area of first coherent, okay, area of one coherent, most probably it will be first. Okay, keep in mind area of one coherent, it will be first coherent always. For convenient we are taking, okay. Then now in this we have to choose this region. So that region is given by 4 times of double integral over the region R into dx dy or dy dx, whatever it is. So in the previous problem we have taken dy dx, so in this problem we have taken dx dy. Okay, so over region dx dy. So since I have taken dx here, so in no place we will write the equation of ellipse. See here, area means we will not take the function. Okay, that is very important, you have to keep in mind. So now I am drawing, since x is the internal operator, I am taking the horizontal strips, that is the strips parallel to x axis. Okay, horizontal. So what we are going to do, we are going to find the area enclosed in the first quadrant, okay. So here this equation is, here x equal to what, this is y equal to 0. Okay, this is y equal to 0 and this line is y equal to b. In x axis we are having x equal to 0 and here we are having the equation of ellipse according to x. So x equal to 1 minus y square divided by b square. Okay, x equal to 1 minus y square by b square, okay, whole power 1 by 2, that is root, whole power 1 by 2 into a. So this will be the equation. So if you want to know it very clearly, means I shall write that can be given by x equal to, so a, b power 1 by 2 is b. Okay, so I am taking LCM here, so I am having a divided by b root of b square minus y square. Okay, x equal to a by b root of b square minus y square. Okay, so I shall give you the solution. 4 times of double integral, the limits of x are 0 to a by b, a divided by b root of b square minus y square, b square minus y square. Okay, b square minus y square, and limit of y is 0 to b, limit of y is 0 to b into dx dy. There is no need to change the order. Okay, here question is not to change the order and evaluate. Here our duty is to find the area using a given order, or you have to find a initial order. Okay, so 4 times of integral 0 to b dx is giving x after integrating. So x, the limits are varying from a by b root of b square minus y square. The lower limit is 0, and dy, that is equal to 4 times of integral 0 to b, upper limit alone will come, lower limit will not come since it is 0. Okay, root of b square minus y square dy. Here we will have 4a by b, 4a divided by b, 4a divided by b. Okay, so we know that root of x minus a square is given by x by 2. So here we will have y divided by 2. Okay, y by 2. Okay, what will be the formula? The formula is given by y square by 2. Just a minute. Y by 2 root of b square minus y square. This is a formula for the given integration. Okay, y by 2 root of b square minus y square, then plus y square by 2, b square by 2 sin inverse of b square by 2 sin inverse of y by b, sin inverse of y divided by b. Okay, y by 2 root of b square minus y square plus b square by 2 sin inverse of y by b. Okay, the limits are 0 to b. The limits are 0 to b. The limits are 0 to b. That is equal to, see, you have to know the formula. Integral root of a square minus x square dx equal to x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a. That is the formula. Using that formula we have obtained this value. Okay, now after substituting b, the first part will become 0 and second part will become b square by 2 sin inverse of, so I am writing 4a by b here, okay, into 4a by b, 4a divided by b. Okay, now so after substituting upper limit we will get, b square by 2 sin inverse of 1. Sin inverse of 1 is pi by 2. Sin inverse of 1 is pi by 2. Okay, pi by 2. Okay, b square by 2 into pi by 2 minus, if I substitute 0, everything will become 0, because sin inverse of 0 is 0 and it will also become 0. So b square by 2 into pi by 2 into 4a by b, 4a divided by b, that is equal to 4ab pi into 4a b divided by a b divided by 4a b square, pi into 4a b square divided by 4b, that is equal to 4 and 4 will get cancelled, pi ab square units. Okay, pi ab square units. Okay, so pi ab square units. I hope you all enjoyed the problem and you know how to consider the area of ellipse under one quadrant, and after that it has to be multiplied by 4 to cover all the quadrants to find the area of the ellipse. Okay, so this problem will be very useful for you. Thank you for watching this problem. Thank you all once again.